Welcome back, guys. Moving on to the next question on the test. Another pretty challenging, tough question. So, two planes are 2,500 kilometers from an airport coming from opposite directions, right? So let's actually just draw that sentence. So let's say this is the airport. We got two planes coming from opposite directions. So plane A and plane B. So let's say that plane A is over here, and then plane B is over here, right? And they're both going towards this airport here. And they are both 2,500 kilometers from the airport, their respective distances. So this here is 2,500 kilometers, and then this here is 2,500 kilometers as well. Now we're told plane A is flying 50 kilometers an hour faster than plane B. So 50 kilometers per hour faster than plane B. So if plane B is flying at, I don't know, 100 kilometers per hour, plane A would be flying at 150 kilometers per hour. So who's going to arrive to the airport faster? Well, plane A. So it means the speed for plane A is greater, which means the time is going to be less. Here, the speed for plane B is less, which means the time is going to be greater. Speed and time have an inverse relationship. And then we're told plane A arrives at the airport 1 hour and 40 minutes before plane B. Right? So basically, what they're saying is that the time of plane B, which is larger than the time of plane A, so time of plane B minus the time of plane A is equal to 1 hour and 40 minutes. Right? So this is the general equation that we are going to be working with, that we're going to try to set something up in order to find the speeds of the planes and the time it took them to reach the airport, respectively. So how can we do this? Well, we got to get expressions for both of these times here. And then once we have expressions for both times, we can then throw it in this general formula, and then we can solve. Just how do we make the expressions? All right, so we know that time is equal to what? It's equal to distance over speed. So what we can do is we can actually set up a chart. I don't know if you remember from, this is from grade 10 actually. You had similar questions. This question is a lot tougher than any question you got in grade 10. But it's pretty similar, where you had like boats, and there would be like the boat speed, the current speed, or you had a plane and the wind speed. Anyway, so we had three columns in those charts. We had distance, we had speed, and then we had time. So let's say this is plane A and this is plane B. Now what distance do they both have to travel? They both have to travel 2,500 kilometers. So this would be 2,500, and this would be 2,500. What about the speed? Well, the speed we don't know, so let's introduce a variable. So let's say we let x equal one of the speeds. And I say we let it equal the smaller speed, and the smaller speed is the speed of plane B. Right? So the speed of plane B is x. Well, what's the speed of plane A going to be then? It's going to be x plus 50, because we know that plane A travels 50 kilometers per hour faster. So the speed of plane A is x plus 50. Now I want to make a comment here. You didn't have to let x equal the speed of plane B. You could actually let it be the speed of plane A. So we could have let this be x. But then the speed of plane B is going to be x minus 50, right? Because it's 50 less. The speed is less. So then that x variable you'd be solving for would be the speed of plane A once we do it after. But again, in this case, I just let it be the smaller speed. So I let it be the speed of plane B. That's what we're going to be solving for, the x. So the speed of plane A is x plus 50. Now, what's the time going to be then? Well, we know time is equal to what? Distance over speed. So the time for plane A is going to be, I'm going to leave a little room here, it's going to be 2,500, the distance, over the speed, x plus 50. That's the expression for the time. Distance over speed. Distance over speed. And then the time for plane B, 2,500 over x. That's the expression for the time of plane B. So now we have expressions for plane A and plane B. We could plug it into this formula here that we talked about initially. So I'm actually, where should I do this? I'm actually going to keep this. So this chart I'm going to erase, so you may want to pause the video, make sure you got this chart, and then I'm going to solve this equation up here. Right? So I'm going to take the time for plane B, 2,500 over x, which is the larger time because it takes them longer, they're going at a slower speed. And I'm going to subtract the time for plane A, which is 2,500 over x plus 50. Okay, and I'm going to erase this here. And the difference in these times is 1 hour and 40 minutes. Now here is where it gets tricky. This is a pretty tough part of the question to catch. This 1 hour and 40 minutes, you have to change it to a decimal, right? So, for example, what is 0.5 hours? That's equal to 30 minutes. How do we get that? Well, we take the number of minutes and divide it by the number of minutes in an hour, 60. 30 over 60 gives us 0.5, or 1 over 2. What if we had 1.5 hours? What would that be? That's 1 hour and 30 minutes. So how do we go from 1 hour and 30 minutes to 1.5 hours? We take 1 plus 30 over 60, which would give us 1.5, or 3 over 2, if you want to keep it as a fraction. Right? So we have to convert this 1 hour and 40 minutes into a fraction like this, or a decimal. So what would 1 hour and 40 minutes be? Well, 1 hour and 40 minutes would be 1 hour, 40 minutes. Let's write it down here. It would be 1 plus 40 minutes over 60 minutes. How much of an hour is 40 minutes of 60? It's 2/3 of an hour. So it's 1 plus 40 over 60. That simplifies to 2/3 if we multiply the numerator and denominator by 20. And then 1 plus 2/3, that's actually a decimal that's going to keep repeating. It's like 1.666 repeating. So let's actually keep it as a fraction. If I take 1 plus 2 over 3, the 1 I would change to 3 over 3. That would give us 5 over 3. Right? So 1 and 2/3 is the same as 5 over 3. So this 1 hour and 40 minutes, we got to change it to 5 over 3 hours, like that, right? And that is one of the tricks in the question. The reason why we have to do that is because this distance is in meters, or kilometers. The speed is given in kilometers per hour, right? Where is it? 50 kilometers per hour faster, which means the time has to be only in hours. There can't be any minutes involved. So we had to take 1 hour and 40 minutes and we had to convert it to hours, which is 5 over 3 hours, or 1 hour and 2/3 of an hour. But better to write it as an improper fraction. And the reason why you want to write it as an improper fraction is because now we can solve for these variables. What you can do is you could get 1 fraction on this side when we subtract these, subtracting rational fractions. And then what you can do is you could just cross multiply. Once you have one fraction on each side, so let's say we got x over 4 equals 5 over 3. If you remember, how do we solve for this x? Cross multiply, but you have to have one fraction on each side. Notice we have two fractions here, so we got to combine those into one. Here, cross multiply, 3x equals 20, so x equals 20 over 3. That's the same process that we're going to take. Okay, so how do we make this into one fraction? Actually, before we do that, the general steps in subtracting rational fractions: factor, restrictions, then simplify. Notice everything's already factored here. What are the restrictions? Well, x cannot equal 0, and then x cannot equal negative 50. Right? So whatever answer we get can't be one of these. And it can't be a negative answer anyway. A negative speed wouldn't make sense, so we ignore that restrictions. And x can't be 0. So this plane B can't be traveling at a 0 speed. Then it's not even traveling. It wouldn't even make sense. So these restrictions we don't really have to worry about, but you should state them in case you get one of the answers being one of the restrictions. You would ignore that answer. But we're probably not going to get that. Anyway, simplifying this left side, so x times x plus 50. That's the lowest common denominator. Both of these factors are different. So this we have to multiply by x plus 50. Top, we have to multiply by x plus 50. This we have to multiply by x to get this. Means the top we have to multiply by x. So here we would have 2500 times x plus 50. And then we'd be subtracting negative 2500x. This is still going to be equal to 5 over 3. Okay, and now here we just have to simplify the numerator. So distribute that 2500 inside the bracket. So we'd have 2500x, and then 2500x minus 2500x, those just cancel out. And then 2500 times 50, that gives us what? 125,000 all over x times x plus 50. Because we're going to be cross multiplying after, I'm just going to expand this. You don't have to. You could expand after, but I'm just going to expand it now. And then this is equal to 5 over 3. Right? Took this, made it into one fraction. And now we can cross multiply, solve for that x. And the way we made it into one fraction, got a lowest common denominator, then multiplied all that out, and the 2500 x's are going to cancel out. You're just going to be left with 2500 times 50, which is 125,000. Okay, so now I'm going to erase this here. I'm going to rewrite this up here. So 125,000. These are some big ass numbers. I didn't realize that these numbers are going to be that big. But let's just work it anyway. So cross multiplying 3 times 125,000, that gives us 375,000. And then here we'll have 5 times this whole expression, x squared plus 50x. And then I'm just going to switch these two sides. So 5x squared plus 5 times 50. Actually, you know what? Let's not do that. You could expand it inside the bracket if you want, but then you're going to have to factor out a 5 after. What we can do at this point is we could just divide everything by 5. These 5's cancel out. What we do to one side, got to do to the other. So 375,000 divided by 5 would give us what? 75,000 equals x squared plus 50x. And now notice we just have a quadratic equation. So we bring this over. 0 equals x squared plus 50x minus 75,000. So now we're just simply left with this quadratic equation to solve. And if you remember from grade 10, there's multiple ways to do this. You can factor, but you're dealing with a pretty big number here. So if you are dealing with big numbers like this, I would actually recommend you just throw it in the quadratic formula, right? Which, as a review, negative b plus or minus square root of b squared minus 4ac. I don't know if you could see that. Like that, all over 2a. But if you did want to factor this, basically, you got to find two numbers that multiply to 1 times negative 75,000 and add up to 50. And the two numbers that make this work out are 300 and negative 250. 300 plus negative 250 gives us 50, and 300 times negative 250 gives us negative 75,000. So we would decompose this 50x into 300x minus 250x minus 75,000. This is equal to 0. And now you just factor by grouping. From these two, you could take out an x, you're left with x plus 300. And then from these two, you could take out a negative 250, left with x plus 300. This is equal to 0. And then from here, you could take out an x plus 300 from both. Remember, the bracket should be the same. If it's not, you're doing something wrong. Then you're left with x minus 250. And this is equal to 0. So this left side is going to equal 0 either when x plus 300 is equal to 0, which happens when x is equal to negative 300, or when x minus 250 is equal to 0. This whole bracket is 0, then the whole left side is going to be 0, and that's going to happen at an x value of positive 250. Remember, we're solving for speed. X is the speed of plane B. Can we have a negative speed? No. So this negative 300 we would ignore. So the speed of plane B is 250. And if you did this quadratic formula at this step, so the B would be 50, the A would be 1, the C would be negative 75,000, you would end up with these two answers right away. But if you want to factor it, you can do that as well. Right, so x is equal to 250. It's not one of the restrictions, so we're good. So that's the answer. That's actually the speed for plane B. So let's actually erase all of this here and make a little chart. So we got plane, you know what, since we got the speed for plane B, I'm going to write plane B first. Then we got plane A. Well, what are the speeds? They're asking for the speeds of both planes. The speed of plane B, which was the x we solved for, 250 kilometers per hour. What's the speed of plane A? Well, 250 plus 50, which is 300 kilometers per hour. It's 50 kilometers per hour faster than plane B. So those are the two speeds of the planes. They're also asking the times. Now, if you remember, what was the time expression for plane B? It was 2,500 over x. Well, we know x is now 250. 2,500, a distance of 2,500 divided by a speed of 250 gives us 10 hours. So that is the time for plane B. That's how long it took plane B to reach the airport. What about plane A? Well, the time for plane A is that same distance, 2,500, over x plus 50, which is 300. And this here simplifies to 25 over 3 hours. Remember, this is in hours. And if you take this, this would be 8 and what? 1/3 of an hour. And what's 1/3 of an hour? That is 20 minutes. 1 over 3 times 60. Remember when we were going from minutes to hours, we're dividing by 60. Well, now when we're going from hours to minutes, we're multiplying by 60. 1 over 3 times 60 gives us 20. So this is 8 hours and 20 minutes. That's the same as 25 over 3 hours, or 8 1/3 of an hour. So there are your 4 answers. Those are the respective speeds. And then the time for plane B is 10 hours. The time for plane A is 8 hours and 20 minutes, which makes sense because plane A is going faster, so it's going to take less time to get there. We mentioned that here. Also notice, what's the difference between these times? 10 hours minus 8 hours and 20 minutes, that gives us a difference of 1 hour and 40 minutes. And we were told that plane A is going to arrive at the airport an hour and 40 minutes before plane B, right? That's what we inputted originally into the general equation. And we could check that with our answers. 10 hours minus 8 hours and 20 minutes, that is a difference of an hour and 40 minutes. But anyway, pretty tough question. Lots going on. You had to set up the rational expressions for the time, subtract the times, that has to equal an hour and 40 minutes, and then you got to change this to be fully an hour. So 1 hour and 40 minutes, that's the same as 5 over 3 hours. Got one fraction by subtracting rational expressions, and then you cross multiply, then you get a quadratic equation. Got to factor it, put it in the quadratic formula, and you solve for that x, which was 250. Now, if you remember, I told you that you could let x be the speed of plane A, and then the speed of plane B would be x minus 50. And if you did that, you would get different expressions for the time, but you would still use this general formula. But then when you solve for x, you would get 300 because you let it be the speed of plane A. Right? So you'd get the same answers, just the format would be different. But anyway, either way, these are the final answers.